You're welcome to another physics lesson. In the last lesson, we talked about motion and how speed, acceleration, distance, and displacement are related, with speed and acceleration having direction, and velocity and acceleration, then distance and speed being scalar quantities without direction. Today, we'll be looking at the equations of motion. That is the relationship between the velocity, acceleration, time, and distance of a moving object, or an object that is at rest that wants to begin to move. We have three equations of motion: the first, second, and third equation. We're looking at them individually, just as you can see on the screen. The first equation of motion is as above: v equal to u plus at, where v is the final velocity, u is the initial velocity, a the acceleration, and t is time. The initial velocity refers to the velocity of the object before acceleration was applied. Remember, we said acceleration is change in velocity, and then the final velocity is the velocity after acceleration. Then we have the second equation of motion, which is s equal to ut plus half at squared. S in this case represents the distance covered. As you can see, the formula is gotten from the average velocity multiplied by time, as you can see above. And then of course t is the time or the duration of the motion being considered. And then the third equation of motion is v squared minus u squared equal to 2as, can also be written as v squared equal to u squared plus 2as. So it's all a matter of knowing when to apply these equations. Like we always say in physics, you bring out your parameters and then you identify which equation to use in determining the velocity, acceleration, time, or distance. Now, what we just explained is equation of motion when acceleration is linear, when it is normal straight acceleration. But then we can also consider motion under gravity. Remember that gravity is the earth's pull on an object, and then we have acceleration due to gravity, which replaces the normal acceleration in the motions of equation. As you can see in the diagrams above, when an object is thrown up, acceleration due to gravity acts on it. We know that the value for acceleration due to gravity is 10 meters per second square, and that means that for every object that is dropping from a height, its speed is increasing by 10 meters per second every second. It gets faster as it drops. So g, acceleration due to gravity, has an effect on all objects ascending and descending. Hence, the equations, as you can see above, are changed with g replacing the normal acceleration a when it has to do with ascension and descension to the earth's surface. Now, when the object is going up, it is working against gravity, and so g is used as minus g, that is minus 10 meters per second square. And then when it is descending, it is working towards gravity, hence g is used as plus g, as you can see in the diagram above. Then we go to projectile. A projectile is an object that is thrown into space and acted upon by only the force of gravity, which takes a parabolic path. So projectile is the object that you throw that takes a parabolic path. In the next slide, you will see what a parabolic path looks like. So for every object, like when you throw a basketball, as you can see in the picture, when you throw a basketball, the path that it takes, if it takes this form of motion in the air is the parabolic path. So if it takes this parabolic path, then the object is referred to as a projectile. Another example is, as you can see above, the cyclist that is jumping from one point to another. It takes the parabolic path, hence both the cyclist and the bicycle are projectiles. This is another example of the water in the pool and the man jumping from a river into the sea. So once the object takes that path, it is a projectile. A projectile has two forms of motion, the horizontal and the vertical motion. Vertical motion being as a result of the gravitational pull of the earth, as you can see in the diagram. Once the object is tossed into space, gravity begins to act on it. So it is either when it is going up, it is working against gravity, and then coming down is working towards gravity, or it just starts coming down immediately if it is thrown from a height. So when an object is projected, there is always an initial horizontal velocity, but the vertical velocity initially is zero. The velocity or the vertical velocity only starts to increase as the object begins to come down. Hence, because of the acceleration due to gravity acting on it, the velocity increases. But for the horizontal velocity, it remains the same. So if an object is projected with 20 meters per second into space, that horizontal velocity of 20 meters per second remains constant until it hits the ground. But the vertical velocity increases because of acceleration due to gravity. And then this is an example of what a projectile motion would be graphically, where t is the time of flight, the time h is the maximum height, as you can see in the graph labeled, r is the maximum horizontal range, or called the range, and then vr, velocity when it hits the ground. So we're looking at these equations individually. The time of flight, this refers to the time taken for the projectile to get back to the same horizontal level from which it was projected. When I throw a ball up, let's assume I'm standing on the ground, the time taken for that ball to return to the ground is what we refer to as the time of flight. And from what you can see, it is represented as 2u sine theta over g, where u is the initial velocity, theta is the angle of projection, and g is the acceleration due to gravity. Then the maximum height, of course, from the diagram we saw earlier, is the highest point that the projectile gets to during its motion. The highest point it gets to during its motion, and is represented as u square sine square theta over g, as you can see above. Then we'll go to the range. The range is the horizontal distance moved by the projectile. That means if I stand on the ground and I throw an object up, wherever it lands, the range of that projectile motion is the horizontal distance from where I am standing to where the object lands. In other words, the vertical upward movement of the object is not considered when you are talking about range, and it is mathematically represented as u squared sine 2 theta over g. So thank you very much. We will do well to